There's one place in the oceans that has particularly sinister fame. In the distant 15th century, Christopher Columbus's expedition faced something that made the whole team panic. The Great Discoverer's Ship Journal contains accounts of the compass needle going haywire, huge spurts of flame appearing out of nowhere, and the sea giving off a strange glow. Many years later, this dead place proved once again how sinister it is. Ships disappear without a trace here. Sometimes they are found, drifting, empty, and completely desolate. But more often than not, we don't even find wrecks. But it's not only the ships that go missing. Planes disappear too. Even entire squadrons of military aircraft. Facts and rumors about these incredible phenomena have quickly spread around the globe. And soon, this region of the Atlantic became known as something sinister. And it continues to uphold its eerie reputation, even today. You've already guessed it. This is the Bermuda Triangle. What kind of supernatural power is hidden under its waters? And what does science say about all this? The Bermuda Triangle. For starters, let's refresh the most notable incidents that brought the Bermuda Triangle its loud and sad fame. The training sailing ship HMS Atalanta left the Royal Navy dockyard in Bermuda for Falmouth, England on January 31st, 1880. The ship didn't reach the British Isles. It hasn't even left Bermuda. It simply disappeared without a trace. It was assumed that the ship sank after encountering a severe storm on its route, and that the crew wasn't experienced enough to handle the situation. At that time, the whole world was eager to learn about the ship's fate. When the ship went missing, the Admiralty received over 150 telegrams and 200 personal calls from concerned friends and relatives. The missing ship made headlines, and the public demanded an explanation. People came up with all kinds of plausible theories, but neither the wreckage nor the bodies of the dead, let alone survivors, were found. HMS Atalanta's disappearance has remained a mystery. The coal carrier Cyclops, loaded with manganese ore, left the island of Barbados on March 4, 1918. A few days later, it disappeared without a trace, along with a 309-people crew. This incident is responsible for the highest number of non-battle casualties in U.S. Navy history. There are many hypotheses regarding the loss of the USS Cyclops. Some people blame a strong storm, others blame the overload and the structural damages caused by cargo, and others even suggest an attack by the Imperial German Navy. But the fact remains, the ship disappeared without a trace in the ocean area that later became known as the Bermuda Triangle. This is a 5-masted commercial schooner, Carroll A. Deering, built in 1919. On January 31st, 1921, it was discovered by the Coast Guard on Diamond Shoals near Cape Hatteras, North Carolina. The ship ran aground, and the Coast Guard was ready to rescue people in trouble. But it turned out that there was no one to save. The ship was empty. No crew, no passengers. Unfortunately, further search efforts for the missing people didn't yield any results. As usual, there are multiple hypotheses explaining this incident, from a pirate attack to the inexplicable disappearance staged by the team itself. Flight 19. This was one of the most famous and sensational incidents, and it happened not with a ship, but with a whole group of aircraft, which inspired researchers to come up with more and more paranormal explanations of the Bermuda Triangle. Flight 19 was a training flight for 5 TBM Avenger torpedo bombers. According to the squadron's flight plan, they had to go 141 miles east of Fort Lauderdale, then 73 miles north, and then back for another 140 miles to complete the training. The aircraft never returned to base. The entire squadron disappeared over the Atlantic on December 5, 1945. Moreover, a further rescue expedition with PNM Mariner seaplanes also ended up in disaster and casualties. One of the mariners also disappeared in the same area, along with a crew of 13. Flight 19 was just the first link in a chain of similar aircraft incidents. In the future, aircraft continued to disappear in this area. On January 30th, 1948, an Avro Tudor 4 passenger plane, also known as Star Tiger, disappeared when flying from the Azores to Bermuda. Almost 1 year later, on January 17th, 1949, another plane disappeared when flying from Bermuda to Kingston, Jamaica. And this also was an Avro Tudor 4, which even had a similar name, Star Ariel. It was as if the devilish triangle favored these particular models. On December 28, 1948, Douglas DC-3 NC-16002 went missing on a flight from San Juan, Puerto Rico to Miami. No trace of the aircraft or 32 people on board was found. The Civil Aviation Board's investigation found that there was not enough information to determine why it disappeared. On September 26, 1955, a pleasure yacht, Connemara 4, was found adrift in the Atlantic south of Bermuda. The ship was empty, with no crew or passengers. The people were never found. It seemed strange that the yacht was intact, and it's unlikely that the crew would have voluntarily left it without a clear threat of drowning. And planes again. On August 28, 1963, a pair of U.S. Air Force KC-135 Stratotankers collided and crashed into the Atlantic 300 miles, 480 kilometers west of Bermuda. There are no more mysteries here. Well, they collided. Such things happen. But again, why in the Bermuda Triangle of all places? One can't help but think that things are not as easy to explain as they might seem. Judging by the dates, you might think that all this happened a long time ago, but that's not the case. The next incident happened just recently. The 29-foot Mako Cuddy cabin with 20 passengers on board was reported missing a day after it was due to arrive in Lake Worth after crossing the Gulf Stream from the Bahamas. It was last seen on December 28, 2020. Looking for the ship or passengers yielded absolutely no results. There were no records of any distress signal. Search efforts involving aircraft and boats lasted 84 hours and covered an area of 17,000 square miles, which is about twice the size of the state of Massachusetts, but to no avail. These are just a few examples. In total, there are dozens of recorded strange incidents that happened in the Bermuda Triangle area. People have come up with all sorts of theories, bold assumptions, and skeptical revelations concerning the Bermuda Triangle and its strange events. And of course, a lot of research has been done in this field. You'll probably be surprised to hear that for all its mystery, the Triangle area is one of the most explored places in the oceans. But it's not only because of the mysterious disappearances of ships and airplanes. Many expeditions were sent to the area of the Bermuda Triangle to study the Gulf Stream, the ocean's influence on the weather, the seabed and its minerals, as well as the geological structure of the Earth's crust deep under the ocean floor. Those who consider the Bermuda Triangle to be a true death trap are right. at least from one perspective. This is indeed an extremely complex ocean region. Huge shoaliness and deep water depressions, a complex system of sea currents, and intricate atmospheric circulation all coexist in this region. And now you'll learn all about it. Let's start from the very seabed. The bottom configuration in this ocean region is well studied. It's even known what lies several kilometers under the seabed. On the Florida shelf, in the Bahamas and Bermuda region, a lot of drilling and geophysical research was performed. There is also an amazing variety of seabed landforms in the Bermuda Triangle, which is hardly found anywhere else on the planet. There is a shelf with shallow banks, a continental slope, marginal and median plateaus, deep straits, abyssal plains, and deep sea trenches. This wide variety is very rare to come by in such a relatively small ocean area. Scientists conducted a planimetry of a large-scale morphological map of the seabed and established that the Bermuda Triangle area can be arbitrarily divided into two parts, the southern and northern ones. The southern one includes the Florida shelf, the Bahama Banks, the Straits, and the Puerto Rico deep sea trench. In this part, the seabed's shape looks very striated. Extensive shoals alternate with straits and great ocean depths. The northern part of the triangle is more calm and has a relatively uniform bottom topography. The wide shelf turns into a spacious deep water plain. In its north and east, some seamounts and a rather large Bermuda Plateau arise. Seamounts? Now this is where it gets interesting. In fact, a mountain is too strong a word, but there are several groups of seamounts in the northern and eastern parts of the triangle. Some of them even have names, but most remain unnamed. The fact is that they're only 150 to 200 meters high. By surface standards, these are not even mountains, but hills. But for the seabed, these are quite remarkable formations. These small mountains in the area have a rather peculiar, almost regular conical shape. Lower cones of less than 100 meters are more numerous, and these are actually called underwater hills. Their round or elliptical shape is easy to notice when looking from above. The slopes of 10 to 30 degrees aren't that steep. The foot can range from several kilometers to several tens of kilometers in diameter. Seamounts and even slopes in this area have a regular shape, which is sometimes complicated by several terraced steps. In the first case, the mountains look just like cones. In the second one, they look like huge plinths with several smaller cones on top. Interestingly, there are much fewer seamounts in the Atlantic Ocean than in the Pacific. In fact, there are around 10,000 individual seamounts in the Pacific Ocean, while the Atlantic Ocean bed has only about 600. And the point is not that the Atlantic Ocean is smaller in size, but that the geology of the Pacific Ocean is more diverse. But in the Atlantic, there are also places with some unusual seabed shape. Perhaps it's not a coincidence that the most interesting configurations are found mostly in the Bermuda region. The islands that lent their name to the entire Bermuda Triangle are precisely the peaks of the largest seamounts rising from the Bermuda Plateau. Some rise from the bottom of the ocean on their own, and others form groups. The original material that formed the seamounts is basalt, but it's hard to see because the mountains are covered with limestone deposits. The limestone platform that forms the bottom of the Bermuda Triangle is a unique geological formation. The limestone deposits here are almost 6 kilometers deep, and all this thick layer is the remains of ancient small creatures. This ocean area is also interesting because the northernmost coral reefs on the planet are found here. And for hundreds of millions of years, the natural conditions that we see here now remain virtually unchanged. In general, scientists haven't even found consensus on the very origin of Bermuda. In 2019, a large international group of geologists published an article in the Nature Journal showing that Bermuda was formed as a result of highly unusual volcano activity. Previously, scientists didn't study such a mechanism of volcanic activity, but it may have contributed to the formation of some other volcanic archipelagos of the world ocean. For many years, it was believed that the ancient, long-extinct volcanoes that once raised the Bermuda Islands from the bottom of the Sargasso Sea were triggered by the mantle plumes. Indeed, a stable plume was observed in this area. On the other hand, such a plume could leave a characteristic chain of islands, such as Hawaii. It emerges as a result of the slow crust movement over a stable vertical magma flow. Also, there's no volcanic activity in the area affected by this flow today. To sort out these inconsistencies, geologists conducted an additional analysis of an 800-meter core from Bermuda back in 1972. They detected a very unusual mineral composition, as well as lead isotopes and some other heavy elements. The research results gave rise to several hypotheses on the origin of Bermuda. According to the most plausible theory, the disruptions in magma flows lifted and mixed the matter fragments of ancient plates preserved in the mantle transition zone. This may seem unclear, but once you understand all this, you'll be surprised. Let's remember that the entire Atlantic Ocean emerged about 175 million years ago as a result of the split of the Pangaea supercontinent, which previously contained almost all of the planet's land. The plates that today form Africa, Europe, and the Americas parted, giving rise to an ocean between them. Numerous plate fragments plunged into the mantle under the ocean bed, sinking into the transition zone at a depth of about 400 to 600 kilometers. About 30 million years ago, mantle flow disturbances made several of this semi-molten debris float higher, while merging, mixing, and interacting with water. Such a process could create not only Bermuda with its unusual geology, but also some other volcanic islands in the oceans. Yep, the Bermuda Triangle was a very unusual place tens of millions of years before it became mainstream. But what rises above the water in the Bermuda Triangle has its opposite, and that's even more interesting. After all, there is nothing but the Puerto Rico Trench. The deepest point in the Atlantic Ocean, the Milwaukee Deep, lies in the Bermuda Triangle. The Puerto Rico Trench is 8,380 meters deep at this point. According to other estimates, even deeper. Perhaps a coincidence? It seems to be a little too much of a coincidence. However, the Puerto Rico Trench is also well studied. In fact, as much as modern technology allows. The 8 to 10 degree slope, located closer to the island of Puerto Rico, is a little steeper. The slope facing the ocean is more moderate and has only 3 to 5 degrees. The Puerto Rico Trench is medium-sized. Its length is 1,550 kilometers. To put this into perspective, the longest trench on Earth, the Peru-Chile, is 5,900 kilometers long. But the Puerto Rico Trench is up to 120 kilometers wide, which is one of the widest ones on Earth. For example, the Marian Trench is twice as wide. The total area of the Puerto Rico Trench's bottom is 186,000 square meters. Science fiction writers often imagine that the deepest parts of the ocean hide mysterious forces and unknown creatures. The Puerto Rico Trench seems to inspire such ideas. However, nothing mysterious or supernatural can be found at its bottom. There are only silts, volcanic ash, and layers of fine-grained sands in some places. Special deep-sea organisms live in bottom sediments and above, such as sponges, holothurians. worms, and other living creatures. And of course, deep-sea fish in the water column. Well, after all, although extremely unusual, the bottom of the Bermuda Triangle still lacks anything completely mysterious. Perhaps we'll find something interesting in its very thickness. At first glance, the structure of the triangle bottom seems unremarkable. Here, one can mostly find regular sedimentary rocks such as limestones, sandstones, and clays. This layer's thickness ranges from 1 to 2 kilometers in the Bermuda Plateau area and up to 5 to 6 kilometers near the Bahama Banks. The average rate of sediment accumulation is approximately 6 millimeters per 150 years. That is, it's safe to say that little has changed in the triangle seabed over the past 120 to 130 million years. But this is only at first glance. There's something in this area that haunts not only mystery seekers, but also quite famous researchers who are concerned about safe seafaring. We are literally talking about a time bomb, a real gas bomb we know almost nothing about, and where and when it will explode. Now this is where it gets really interesting. In the hopes of explaining some of the strange ship disappearances, scientists and enthusiasts are desperately trying to balance between bold hypotheses and a rigorous scientific approach that rules out hoaxes. Therefore, there aren't so many bold theories. One of them concerns eruptions of methane hydrate deposits, a special form of natural gas. The presence of large deposits of methane hydrates on the continental shelves has been scientifically proven. The only question is whether the rapidly released masses of these substances can sink a ship. Some very serious experiments were performed to find it out. For example, a group of Australian researchers conducted a series of simulations. The results were actually promising. When experimenting with smaller ship models, artificial gas eruptions sank the models quite easily. This was due to a sharp decrease in the water density. It has been suggested that intermittent methane interruptions may create areas of foamy water that can't provide sufficient buoyancy for ships. Such an area formed around the ship could cause it to sink very quickly and unexpectedly. Hence the lack of distress signals. They simply couldn't be sent in time. The debris would then be quickly swept away and scattered by the Gulf Stream. Hence, the disappearances are very hard to trace. U.S. Geological Survey publications describe large subsea hydrate reserves around the world, including in the Blake Ridge region near the coast of the southeastern United States. Now, everything seems to add up. But according to the same geological survey, there have been no major gas hydrate emissions in the Bermuda Triangle zone over the past 15,000 years. I don't want to talk about any conspiracies here. Moreover, there exist a lot of well-founded explanations debunking the mysterious nature of even the most high-profile disappearances. But mysteries attract inquisitive minds. No matter how overrated the Bermuda Triangle is, no matter how far-fetched its secrets are, it inspires the curiosity of whole generations. And it's in the pursuit of mystery that humanity often discovered the true nature of phenomena that quickly turned from fantasies to indisputable facts.